Example 1.1 Converting speed units. The world land speed record of 763.0 miles per hour was set on October 15, 1997 by Andy Green in the jet engine car Thrust SSC. Express this speed in meters per second. To solve this problem, we first write down the value we want to convert. This value. This value is equal to the same number with its original units, multiplied by fractions that allow us to cancel the unwanted units and introduce the desired ones. The units we want to eliminate must be in the opposite position, numerator or denominator, in the conversion fractions compared to their position in the original units. In this case, since miles are in the numerator of the original units, we will place miles in the denominator of the conversion fraction. These conversion fractions have equivalent values in both numerator and denominator. To convert miles to meters, we must know that 1000 meters are equivalent to 0.6214 miles, and to convert hours to seconds, we must know that 1 hour is equivalent to 3600 seconds. The conversion factor between meters and miles was taken from this table. The conversion factor between hours and seconds must be memorized because it will be used frequently. Now we can cancel miles and hours since they are on opposite sides in the product of the conversion fractions respect to its position in the original units. In this way, the remnant units are meters per second. When we calculate these operations on a calculator, we get 341.08 meters per second. Now you might be tempted to round the result to 5 significant figures, as here, but that would be incorrect. We need to round this to 4 significant figures. Significant figures are important, and since our original value has 4, we need to round our answer to match. Remember, zeros to the left don't count as significant figures, so we have 4 significant figures here. To round, we look at the last digit. If it is greater than 5, we round the previous digit up. In this case, we round the 0 up to 1. Therefore, 763.0 miles per hour is approximately 341.1 meters per second. So far, we've mastered converting miles per hour to meters per second using a direct conversion factor. But what if that specific conversion factor wasn't readily available? Or what if we simply remember it? The beauty of this method is that it's flexible. It allows us to use other conversion factors that we might already know or can easily find to achieve the same result. Let's say, for instance, that we don't remember the direct miles to meters conversion factor, but we do know how to convert miles to kilometers, and also we do know how to convert kilometers to meters. We can use those conversion factors in a chain to get to our desired units. We start with our original value, 763.0 miles per hour. First, we multiply by the conversion factor that relates miles to kilometers. We know that 1 mile is equivalent to 1.609 kilometers. We put miles on the bottom, as you can see on the screen, so that it cancels out with the miles in our original value. Now our miles cancels out, leaving us with kilometers per hour. Next, we bring in our second conversion factor. 1 kilometer equals 1000 meters. We put kilometers on the bottom to cancel with kilometers we have now. Kilometers cancels out, and we are left with meters in the numerator. Exactly what we want. Finally, as we did before, we use the conversion factor between hours and seconds. 1 hour is equivalent to 3600 seconds, positioned to cancel out hours. Now we are left with meters per second, our target units. Now it's time to perform the multiplication. On the screen we have our original value, 763.0, multiplied by 3 fractions. To make the calculation clearer, let's express our original value as a fraction as well, by simply putting it over 1. To perform this multiplication, we will multiply all the numerators together and then divide that result by the product of all the denominators. That results in a value that, initially rounded to 5 significant figures, is 341.02 meters per second. However, our original value has 4 significant figures, so we need to round our result to 4 significant figures as well. This gives us 341.0 meters per second. This is because the digit to be dropped, in this case the 2, is less than 5, so the last significant digit, the 0, remains unchanged. If we compare this result with the one we obtained earlier, we see that they are slightly different. We have a discrepancy in the tens place. In the first method, we got a 1, and now we have a 0. This discrepancy can be explained by considering the precision with which we initially stated the conversion factors, at least for the inexact values. By using more precise values for our conversion factors, we should get results that are even closer, and that is exactly what we will explore in the next part. To find more precise conversion factors, we can use online tools like Google Unit Converter. Doing so, we find these values. 1000 meters is equivalent to 0.621371 miles, and 1 mile is equivalent to 1.60934 kilometers. Both of these values have 6 significant figures. Let's clarify the difference between significant figures and precision. Significant figures include all the digits in a number that contribute to its value, both before and after the decimal point, except for the leading zeros, which do not count. Precision, in the context of measurements, usually refers to the number of decimal places, or how finely the measurement is specified. In this way, our two new conversion factors have the same number of significant figures, 6, but the mile to kilometer conversion has a different precision because it has 5 decimal digits compared to 6 in the meter to mile conversion. Notice that if we round these new more precise values to 4 significant figures, we get 0.6214 for the meter to mile conversion and 1.609 for the mile to kilometer conversion. The same values we used initially. We can do it as exercise. We have that 1000 meters equals 0.621371 miles. First, we want to eliminate the last digit, the 1. It is less than 5. Then the 7 remains unchanged. Next, we must drop the 7. We see that it is greater than 5. Then the 3 increases by 1. So it becomes 4. Finally, we get that this number, rounded to 4 significant figures, is 0.6214, the same that we used before. Now, if you do the exercise with the second one, you must obtain that 1 mile is equivalent to 1.609 kilometers. It's time to return to our units conversion using these more precise values. The setup is the same as before, but we will use our new, more precise conversion factors. Performing the calculation with this new factor, my calculator displays a result of 341.091625, taking all digits that appear in it. I do it to show you how this number is rounded until we get 4 significant figures. We start considering the last digit to the right, the 5. When we want to drop a 5, we must see the digit to its left. If this is odd, then increases by 1, like in this case. If it is even, it remains unchanged. Then in this case, we must eliminate the last 5, and the previous digit, the other 5, increases by 1, because it is odd, so it becomes 6. So the original number 341.091625 with 10 significant figures can be rounded to 341.091626, which has 9 significant figures. With this new rule, we get all the cases for rounding numbers. When the digit to be eliminated is less than 5, greater than 5, and finally when it is equal to 5. Applying these rules repeatedly, we can continue rounding until we arrive at our desired 4 significant figures. You can do a similar procedure in the other case. In this way, we can see that the result with 4 significant figures is the same in both procedures. And that's it for our deep dive unit conversions. I hope this cleared up any confusion about direct and chain conversion methods, significant figures, and rounding. Remember, using more precise conversion factors will generally lead to more accurate results. If you have any other physics topics you'd like me to cover, let me know in the comments below. Don't forget to like this video, subscribe to the channel, and hit that notification bell so you don't miss the next one. Until then, keep exploring the fascinating world of physics, and I will see you soon.